Okay, in this example we're going to look at a slightly trickier, although not a lot trickier example of a locus that doesn't form the equation of a circle. We'll start by remembering an example of the ones we did in the last video. I wanted to know all the points where the complex number z, all the points that are made up by the complex number z, where it is a distance or radius or modulus of 5 from the point 4. What if we looked instead at an example where the condition on the left had to be equal to a different condition on the right hand side? So this is the points where z is the same distance from 4 as it is from 10. Here I've plotted both those points, and we're finding the point where this distance is the same as this distance from the right hand side. Obviously this point satisfies the equation because the modulus of z minus 4 is the same as the modulus of z minus 10. But also any point along this vertical line, you can just imagine, is the same distance from the blue point as it is from the red point. The equation of this line will be x equals to 7, which is halfway in between. Right, so here's an actual example. What if we took z minus the complex number 3 plus 4i, the modulus of that, and equate it to the modulus of z minus the complex number negative 2 minus 6i. So here's the 2 points plotted, and you can see that the line will just be a straight line which goes somewhere along there, not sure exactly where. Any point on that line will be equidistant from both the blue and the red points, 3 plus 4i and negative 2 minus 6i. Looking at this algebraically now, if I set it up in the same way that we did in the previous videos, except on both sides we have a condition like this, and remembering that z is the complex number which can be written in its real and imaginary parts separately, x plus iy, and substituting that in for z on both sides. Also, I'm expanding out the brackets, so you can see the negative has been imposed on both parts of the bracket. Once again, I'll move the real parts to the front and the imaginary parts will be separated down the back. Now, we established in the last video that the modulus or radius could be written as the square root of the real part squared and the imaginary part squared. So I'll do that here on both sides, and the next line I'll simply remove the square root from both sides. I'll square both sides and it will cancel off the square root. Just a bit more space. Expanding all these brackets, just using quadratic expansion, and then I'll need to cancel off the like terms on both sides, and lastly I'm going to shift all the x terms to the right, all the constant terms to the right, oops, that should have been a y, all the y terms to the left. Now, gathering together all the like terms, this will be simplified to negative 20y equals 10x plus 15. And to divide both sides by negative 20 to get the equation y equals negative a half x minus 0.75, the equation of a straight line. Just to plot this again as I did earlier, and here's the line as it should look roughly in a sketch.